In this lesson, I'm going to do an introductory discussion of trig equations and how to solve them for different types of equations. First of all, a trig equation is one that has unknown angles that need to be solved. A couple of examples are given here. They can be as simple as sin x equals 1/2 with unknown angles to find, or something like a quadratic trinomial with trig terms where we would actually have to factor and solve for each part. There are two types of solutions that get asked for. One is a conditional solution, which is typically for one full turn angle, such as 0 to 2 pi radians. That's the most common, but you may be asked for a general solution, which represents all solutions and considers periodicity by adding 2 pi or 360 degrees in multiples. There's a few steps to solving trig equations. First up, you need to isolate all the terms to one side of the equation, then factor any common terms, or common factors if there are any. Don't divide out factors though. I'll show what can happen when you do this. If there's more than one type of trig function, attempt a substitution by using identities to get to one type of trig function. And lastly, pay attention to the period and adjust solutions if necessary if the period is not the normal period for the function. So I'm going to do 3 examples in this lesson. The first is this equation given 2 sin x equals -√3. So my first step will be to isolate the trig term to one side and any constants to the other side. Now, hopefully I recognize that that ratio represents the reference angle of pi by 3, and with sine being negative, I know that I'm dealing with quadrants 3 and 4. So I need to put a pi by 3 angle into quadrant 3 and 4. The roots for x then are 4 pi by 3 and 5 pi by 3. Now, we can use a graphing calculator to look at these answers. The way that I'm going to do that in this lesson is isolate everything to one side. So in this case, add √3 to both sides of the equation, and then look at that representation graphically. So I've got the first one already loaded in the calculator. First up, make sure you're in radian mode. Go to y equals, and you can see I've entered the equation with √3 being added on the left side. Now, the amplitude of 2 sin x is plus or minus 2, and then √3 is being added. So I need to go as high as about 4 and down to perhaps 0 when I set the window. You can see that I go from 0 to 2 pi representing the conditional solution, and my y min I'm going to adjust in this case to 0 and 4. So I'm going to graph this, and I should see a sinusoid, and I realize that I want to see below the axis as well. So I'm going to do a little adjustment on my range and make my minimum -1 to 4 so that I see that little bit of the sine curve going below the axis. So there are 2 solutions I'm looking for, this one and this one, and I'll find one of them to confirm my answer. It's called a 0, and I have to set a left boundary to the left of the 0, and the place I have is sufficient, and I'll move the cursor until it's to the right of where that 0 is. That should be good enough, and then a guess value somewhere in the interval, and I get a result of 4.18 approximately. And if you consider 4/3 being 1.3 times pi, that's that root. So that's confirmation of the value that I got. And I'm just going to copy the solution right in here to show us graphically those 2 answers. So the one root is right here, the other root is right here. Okay, a more difficult problem. Cos x sin x equals cos x. Now, what many people do is divide by cos x, and they would get sin x equals 1. This is wrong. You don't want to do this because you need to consider that cos x can be 0, and therefore you would be dividing by 0 when you perform this action. And we don't want to divide by 0. So instead, what we're going to do is we're going to factor. We're going to bring both terms to one side of the equation. So there's nothing on the other side of the equation. I'm going to remove the cos x common factor. writing the remainder in the bracket. Now, when two products multiply to 0, one or the other needs to equal 0, and this causes me to be able to write these two expressions. It's called the zero product rule. Now, cosine of an angle is 0 and sine of an angle is 1 at quadrantal angles. So in this case, x equals pi by 2 or 3 pi by 2. And in this case, x equals pi by 2, which is a repeat of the last answer. Now, if I wanted to write a general form solution to this, consider that the period is 2 pi, so my roots would look like pi by 2, odd values, 1 pi by 2, 3 pi by 2, and so on. So I can write odd as 2n plus 1 pi by 2's, where n is an integer. You want to define what n is. All right, I got one more example for you in this first part of the lesson, and in this case I have a sine function on both sides of the equation. What I want to do here is gather all of the sine terms to one side, then isolate sine, and you'll see in this case that this ratio is not a special angle. So I'm going to need my calculator, and I'm going to write arc sine of negative 1/3 and find that value. So let's put that on the calculator. Excuse me. And I'm going to go to the home screen, make sure I'm in radian mode, and I am. And I'm going to do arc sine of negative 1/3, and I'm going to get the answer of negative 0.3398. Negative 0.3398. Now your calculator will always give the smallest numerical result for angles, even if it has to give a negative angle. This is really a quadrant 4 angle, so if I add 2 pi to this, I'll form a positive angle between 0 and 2 pi, which is the kind of answer that I want. Remember, conditional answers are 0 to 2 pi typically. So I want to write 5.943. So that's what I'm going to work with, 5.943 radians, and I'm going to get some strange decimal radian values when I don't know the ratios. Now, the other angle is going to be in quadrant 3. So the quadrant 3 value of x is going to be pi plus that decimal value I had, which represents the reference angle. So let's get that on the calculator, and we write pi plus 0.3398. That negative sign was there to just tell me it was in quadrant 4. So 3.481 radians is the other answer in standard position for the condition 0 to 2 pi. If I wanted to talk about the general form of the solution, again, these are 2 pi period answers, so I would just add 2 pi n to each of these, where n is an integer. And that's how you do fairly basic representations of trig equations. In the next lesson, I'm going to cover some more complicated ones where there's a few tricks and traps.